My name is Rolando, and today I will be determining the sample size necessary for estimating the difference between two population proportions. I'm using a problem from our book from page 481. It's problem number 39. A physical therapist wants to determine the difference in the proportion of men and women who participate in regular, sustained physical activity. What sample size should be obtained if she wishes the estimate to be within 3 percentage points with 95% confidence, assuming that she uses the 1998 estimates of 21.9% male and 19.7% female from the U.S. National Center for Chronic Disease Prevention and Health Promotion, and B, she does not use prior estimates. This is the formula for determining the sample size when you have prior estimates, and this is the formula that you would use when you don't have prior estimates. You can refer to page 478 if you need to look at the problems. First thing we need to do is identify p hat 1, p hat 2, and the margin of error. P hat 1 is given to us with 21.9%. We turn that into a decimal form, which would be 2.19%. P hat 2 is given to us in the form, in the question as well, and is 19.7%. We turn that into decimal, which would be 1.197%. And our margin of error is given to us in the sample, in the example as well, which is within 3 percentage points, and that would be 0.03. Now we have to find alpha. To find alpha, we do 1 minus 0.95, which gives us 0.05. 0.05 divided by 2 is equal to 0.025. Then we would use our calculator function inverse norm, which equals 1 minus 0.025, which gives us 1.96. 1.96 divided by our margin of error squared will give us this value right here. And it's important to say this value right here because we can use it in the formula when we don't have prior estimates. Now that we have all our values, we just plug in our p hat 1, our p hat 2, and the value that we just solved for, and we get that n is equal to n1 is equal to n2, and it's 1405. But it's important to round up to the next integer, so our sample size needed for part A would be 1406. For part B, since we already have this value, we just multiply that by 0.5 and we get 2134, and once again we need to round up to the next integer, so part B would be, our sample size would be 2135. So in conclusion, the physical therapist, given the prior estimates, would need a sample size of 1,406, and not given prior estimates, would need a sample size of 2,135 people.